Welcome to aminacademy.com. In fluid mechanics, let us do some example problem regarding float valve. The problem is given here. Then we'll start the problem now. Specific gravity of oil 0.8. Therefore, rho 0 is 0.8 into 1000 equal 800 kg per meter cube. Diameter of the float equal 15 centimeter. This float is here 15 centimeter, which is equal 0.5 meter. Angle AOB. Here let the point A is here, OB. Angle AOB is 135, that is here. So it is 45 by geometry. OA is given as 20 centimeter, 0.2 meter, here 20. Then here this oil supply, then P, force applied is 9.81 Newton. Then OB is 50 centimeter, 0.5 meter. In triangle, by geometry, in triangle BOD, BO the triangle D is here, suppose. In triangle BOD we can see sine 45 OD over OB. OD is OD we can say OC plus OD equal OC plus CD by OB. Here OC is 35. We can put it in centimeter because the ratio. Therefore, plus H over 50. Therefore, sine 45 is 1 by root 2 equal 35 plus H over 50, which gives H equal 50 over root 2 minus 35. So by calculation it gives 0.355 centimeter, which is equal 0.0035 meter. The weight of float is acting through B. The weight of float acting through B, but the upward buoyancy force is acting through the center of the weight of the oil displaced. So the volume of volume of oil displaced equal 2/3 of volume by r cube, because here the float hemisphere, half of the, that means this point is coincide with the level of water, so it is half of the sphere is submerged in a water, so it is the volume is 2/3 pi r cube plus pi r squared h, pi r squared h volume of the cylinder. Now, so we'll put the values 2/3 pi, r is 0.075 cube, because it's 15 divided by 15 centimeter is 0.15 meter, which is divided by 2 is 0.075 cube, plus pi into this r is 0.0075 square into h is 0.00355. So it's give final calculation, which gives is equal 0.000945 meter cube. Therefore, buoyancy force, buoyant force is weight of oil displaced. Weight of oil displaced. Here, volume of oil displaced is given, that is first rho g into volume 0.00945. It is 800, because rho is 800, 9.81, 0.000945, which is equal to 7.416 Newton. That means this buoyant force here, that force is transferred to the float wall. The buoyant force and weight of the float passes through the same vertical line, passing through B. Let the weight of float, now let the weight of float equal W Newton, Therefore, we can say net vertical force is buoyant force minus W, weight of the float, which is equal 7.416. Here, this buoyant force 7.416 minus W. Now, taking moments about hinge O, that is P into 20, force P into 20 is equal 7.46 minus W into BD. Taking moments about the hinge. Hinge O. That is force P into 20 equal net vertical force is 7.416 minus W into 50 cos 45. 50 cos 45. That is here that we have to find BD. That BD is 50 cos 45 because this is 50 cos 45 of this line BD now. Therefore here from that we'll P into 20 equal 7.416 into 50 cos 45 minus W into 50 cos 45. By solving we'll get P is already 9 point. We can put here P equal 9.81 given. From that by solving we get W equal 7.81 into 20 minus then therefore W by using rearrangement and calculation W equal 1.866. Newton. Therefore, weight of float one point eight 1.866. You can put it as it is Newton. We have done. Please subscribe our YouTube channel.